fraction, couldn't I? I could have messed up 4 to the 4th, true? Right? All right. Oh, and what's 390? Is that a 400?
Yeah.
What's 400 subtract 2.5?
397.5.
397.5.
5.
Is that okay then?
If you could possibly do one that uses the first one, the very first equation at the top.
Oh, that was the theory behind all this. That was with Riemann sums. So we don't have to do that anymore.
That we did the other day.
Yeah, that was just the idea of where it came from. Remember we started with building all those rectangles last class? What we had, we were off. We were what? Estimating, true? Then we thought, theoretically, what if we built what? An infinite amount of rectangles. This is what it turns into. And that built us to here. So that's called the definite integral and led us right to here. So that's what that is, right? That's more what? The theoretical statement, what it's coming to. Ah, yeah. Sum an infinite amount of rectangles. Set it to infinity and you get it. Hey, can I erase? All right, I went tough one.
All right.
What were all those rules for derivatives? What were all those rules for derivatives?
Product, chain.
Remember those? Have we had any yet for this?
No.
Oh, I mean, the only rule we're doing is what? The opposite of the power rule, true?
Mhm.
You go, well, are we going to hit any rules? I'll be honest with you, we hit one rule. But we don't get to it until the last section. We'll talk about it tomorrow. Okay? We'll talk about it tomorrow. So, if we got no rules, now this time everyone, I'm not putting limits on here. So, is this going to be an indefinite or definite?
Indefinite.
Want to look at my back? Look. Evaluate the indefinite integral. You'll see some of these. I made sure to select some of these from the textbook problems. Okay. 5x to the 6th. Give it a shot. That's a dx off there. Josephine, don't forget at the end we're putting a plus C, right? Now,
Done.
look. This could freak you out during a test. Because you're thinking, what, quotient rule? That was for derivatives. And this is integrals, right? This is integrals, and all we know is what? We can take this x squared and make it like x cubed over 3, true?
Mhm.
So how, who's got a way to get around this problem? Who's got an idea?
You can make it simpler and just cross out the x's.
What do you mean? What do you want to? This is bugging me, this whole gigantic complex fraction.
5x cubed minus 3 over x squared.
Yes. Everyone, he's splitting up the fraction. That's what he's doing. He's splitting this into two separate fractions. He's saying, look at this as 5x to the 6th over x squared minus,
3 over x.
all right, outstanding. If we didn't do that, I'll tell you what, we've been staring at this for hours. We've been going, quotient rule or, opposite? What's the opposite of a quotient rule? And we were trying to figure it out. That's going to do it. We had to split this into two. Now, if you're curious, like, well, what happens when there's like a binomial down here? That's coming up. That will come up later. So, can you help me simplify that? What is it?
Yeah. 5x cubed over 4.
Now, be careful here.
3 to the x cubed over minus 2.
X to a negative
2.
2. Don't agree? Now, when I still haven't done the integral yet, so I got to keep the what?
Dx.
Dx. Kel, you okay with that?
Yeah, yeah.
Now, let me tell you something. Heads up, everyone. I get it all the time. Class size of 25 calc students. Sometimes up to 10 students will tell me the integral of this is negative 3 ln of x squared.
No.
Be careful. What's the only one that becomes the ln of x?
1 over
You
x.
remember? Only this guy, right?
Mhm.
I'm going to agree is natural log of x plus c. Don't forget that. So is this a natural log right there? No. But I think after this I should do one, so one sees the difference. All right, this will be easy. What's the integral of 5x to the fourth?
X to the power 5
Good deal. What happens to those 5s?
cancels out. The
-2. And we be careful.
-1,
Be careful. You gotta raise -2 by how much?
1.
Sometimes people, it's a number line thing. What's -2 plus 1 in math? Not -3, but.
-1.
And then I gotta divide by that number.
-1.
There you go. Be careful. That's another common error. People accidentally do -3 over -3. It happens. Oh, don't forget I have to put the plus what?
Plus,
I have to put this y. Plus constant, antiderivative. Now, and we should definitely simplify that. Could you tell me this in a nice simplified manner? X to the 5th.
Plus,
That minus and that minus means the what?
plus,
That 3 is up top. And where can I move an x to the -1?
below.
That's the best way to write it. If you want to combine these fractions, you can, but I would just leave it like this. That puts a smile on my face. You got it. You had to substitute 1s or 2s or 3s, you'd be okay right there, right? Yeah. Now I want to wait till everyone has this, and we're going to change that bottom to an x. Because then you get to an L and x, right? Then the natural log comes up. Great job with this. Everyone okay with that? Yeah? Yeah? Alright, here it comes. I just want to know the answer. Well, what happens here?
That will be 3 natural log of x.
I'll just write that again. Let me wipe that out.
3.
How does this work? The 3 is the constant,
Mhm.
but we know the integral of any 1 over x becomes what?
Wouldn't it be 5x to the 6th over x, not x squared?
5x to the 6th over
Oh yeah,
x.
5. It will be 5. Yeah, she's right.
I gotcha. And so this would be what right here?
X over 5. Yeah.
And this would become a
5.
5. And I'll put this right down. Good. Josephine, what would this be? 5x to the 6 over.
6.
Now, how about this guy?
That
The
should be
3, let it sit there like a constant.
Mhm.
But what's the antiderivative of 1 over x?
natural log of
Natural log, and what do I gotta put on
absolute
this?
value.
Yeah, put a little absolute value bar around it. What's that for? Well, we can't get the absolute, you can't take natural log of negative numbers, right?
Do you have to give that like for this x then, or do you have to give it the thing like when from negative infinity to 0 union 0 to infinity?
Nope, you wouldn't even have to write that.
Okay.
Good question. Good, I got you, because you're like element 0 is undefined.
Yeah, exactly.
Very good. You're gonna like calc too, because you do something called improper integrals.
Uh-huh.
And people do stuff like that. They go, da-da-da, da-da-da, and then they go to like stuff like this. And when that's calc 2. And you're like, wait a minute, what's the natural log? What is that number?
0
You go, what's the natural log of 0?
undefined.
Undefined, but when you think of this graph, look at it. It goes like this, right?
Uh-huh.
And the idea of calculus is maybe the area in there converges to a number. Isn't that cool? That's the idea. It's called, don't worry, it's not in our course, but it's called improper integrals. And you got to think about it. You go, yeah, maybe the area in here what? It gets so tight so quickly, maybe it converges, and there you get the limits again. And so you go, oh, it's like a limit approach into that.
There's like something like Taylor and Maclaurin series, something like that.
And that's right after that.
Okay.
That leads to the Maclaurin series, that's
Yeah.
right. But isn't that cool? And so I just want to point out, sometimes they call them improper integrals. So everyone, by accident, I might be up here just making up problems. Somebody may catch me and go, whoa, 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 professor, that's an improper integral. Because I can make sure I don't do something like that. Put an integral over like an asymptote or something. You follow me? Like, I can't have you do this today, look. Everyone, let's do 8 over x squared, right? And I go from -2 to 3. I can't do that. You know why? This function, what's going on at 0? It's undefined. This function has an asymptote at what? It's got a vertical asymptote at x equals 0. I just broke right through the middle of it. It's called an improper integral. So if I accidentally write one of those, someone can call me on that, okay? All right, I'm gonna finish this up. That became this became that. Is everyone okay with that answer?
Mhm.
Is everyone okay with that? Yeah? But be careful, what if this was 3 over x squared? No natural log, right? Good. Hey, speaking of these, I always get a kick out of this. Look. You go from like 2 to 3. And you gotta find this integral. Foreman, what's the integral of 1 over x?
Natural log of x, but you
With
have
the
to
bars.
plus
You gotta put a 3 and a what?
2.
Foreman, there are only, there's only like 3 log properties. I always get a kick out of this. My students are so afraid to use those log properties. They leave their answer like this. Do you remember log properties? Another way you
You
can write
can
that?
divide them.
Did you know this? This is a property of log, that you could write it like that. I just want to point that out. Keep in mind those log properties. I can write this like this.
Will we get it wrong?
It's kind of property of log. See, I knew
No,
that was coming up.
No, you're
I
not
knew that was
going
coming.
wrong, but you can write it.
It's good to do that. Hey, Bill Reg, I'll be honest. My midshipmen, they'll never do it. You know, they'll always leave it like what? Natural 3 minus natural log of 2. But I want to point out, there's not like there's 50 log properties. There's only these what? 3 simple log properties, and this is one you can always do that. Cool? So I want to point that out. Plus, I think it's good to do that because you might check the back of the book and go, I got this. How did they do that? You go log properties. Okay? Good deal. All right. And when here comes another special case. Special functions. You got trig functions down, right? I give you a polynomial, you smash that. I give you that, they call that a rational. I had a rational function up there, you crush that. How about this guy? There's 2 ways to do this. Evaluate the indefinite integral. Give it a star. What's special about it? Come on, there's something
So
special
you
about
have
it.
to find the
Do you see
critical.
what I got there around that x plus 2?
Yeah,
What are those?
absolutely.
Absolute value bars. So there's 2 ways to do this. One of them is algebraic approach. Another approach is geometric approach. You know why? Everyone, the absolute value function. The absolute value function. What does the function look like in an image? A what? A V. And think about that. I want you to think geometrically like, oh, I can make little triangles, right? So we're going to do this problem 2 ways. I
No,
think on a test, I'm going to give you the option. Does that sound cool? Does that sound fair?
uh-huh.
I'll say, you got to show me this geometrically, or you got to show it to me algebraically. And we'll do it both ways.
This is just a random question, but on the integral table itself, does the lower value number always go on the bottom, or does it really matter?
Yep, it always does. Now, did you see what I did here? That was a Professor Messenger error. I meant to put what here?
-2.
Well, I actually meant to do this. Okay?
Right.
But I got to answer that.
So
The
the lower
professor.
value number does always go on the bottom?
Let me write down, and we're going to do that problem. Thanks for spotting that. Now, what did I have originally? And I'm going to write this. We'll talk about what did I have originally?
4,
Negative 2 on top of
4 and -2.
So I'll make up, well, I'll just make up some bizarre, weird ones, but I'll put this number higher, like 8, and -3. So if you ever get a problem like this, the very first thing I want you to do is switch these so the lower number's here, and then what do you got to put in front? Tell me.
Negative.
Put the negative. So that's what I want you to do. So Josephine, you ever get this? Anybody in this class, you ever get this? Right away go, I'm going to put a negative down, because we always want to think lower limit, lower value, upper limit, upper value.
Now, professor,
Cool?
however, you can do it in that way too, like 8 and 3, but you have to take negative x over it because -2 is a cut point and -3 is
That's
left.
right.
Right. you can
That's
do that.
exactly right. So that's a good habit in it. And I'll be honest, I didn't mean to do I wrote it that way. But it's good to think that way, right? So if anybody ever does that, you can go, oh, this is equivalent to this. And then you can rock and roll. Cool? All right, now. Let's do this 2 ways, but on a test, you're going to pick your what? Your favorite way. Now, let's start with the geometric approach. What does that mean? Oh, you and I are doing what? Geometry? We're drawing a graph. Now, who has knowledge of this V function? It's shifted 2 notches, that way or this way?
So
If you just set that
left,
equal to 0, you'll know.
left to the left.
Good deal. Goes to the left too.
Mhm.
But we gotta make a really nice graph, okay? So you said it went left too.
Mhm.
Okay. There it is. Now let's plug some numbers in here. What's going on with this function at like -3? Because you gotta go from -4 all the way to what?
2.
So let's make a really nice sketch. You're telling me this function's gonna hit right here, right?
Mhm.
Now I want just tell me what's, what you plug an -3 in there, it's a what? It's a 1, how high does it get at 4? How high does that get? Does it get up to 2? Alright, how high does it get at 1? How high does it get at 2? Alright. And what am I making the graph correctly? But how far do I gotta go out to with this graph? I gotta keep going all the way out to what?
2.
Now who could tell me how high does that get at 2?
4.
So at 2 it gets up to 4, does everyone agree? Just plug a 2 in there. And we just plug a -4 in there, it's 2, right? Now, what's this integral? Oh, I see 2 triangles, do you? You all see 2 triangles?
Mhm.
Here, I'm gonna shade them. Finds area under function. This function's not going underneath the x-axis. Everyone, I need a half base height on that dude, and then I need a half base height on this dude. Just be careful, okay? Just be careful. What's that base right there?
-2 to 4 is -2.
That base length is 2. What's that height right there?
What is that? 4. 4 is what? 2?
2 times 2 is 4. What's half of 4?
2.
Is it 2? So can I put a 2 in here? Can I?
Yeah.
Okay, what's that area? Be careful. Look at that base. Look how far it is. How far is it?
-2 to 2. So that's 4.
4? 1/2 of 4.